Hello, welcome back to another video in this series of Python for Gen AI. We have already learned about Python fundamentals, and then we reviewed the data structures and file handling in Python. Today we are going to review object-oriented programming or classes in Python. So let's dive in. So this is chapter 3 in this series. Let's review this because this is very important in your programming career. We write a lot of classes when we write big libraries or software. So this is a core and fundamental for every building block that you see or use in your day-to-day Python. You might be able to create beautiful code when you write classes. In the beginning it sounds intimidating, like the concepts are a bit confusing and you feel like that, but when you keep practicing it you really love them and you write really good code. So let's see what object-oriented programming is. So it's a programming paradigm that uses objects to model real-world entities. Okay, so that's a definition, but you think of them classes as blueprints, for the building or for the car, right? Then once you have that blueprint, you can actually build in different variations, like you build maybe with the bricks or maybe with the wood, and then you paint various different colors. Those are the instances or objects that you decide, such as properties or behaviors, right? So that's how this work. So what are the main important topics that we're going to cover today are classes, objects, inheritance, and polymorphism. Okay, so don't worry whether these words are so new to you, but it's okay. You keep writing functions, that's okay. As you write functions over and over, you may feel like they are kind of redundant, and sometimes you want to go further. Then you jump into the classes. It happens automatically, you don't need to jump in right away, but learn them, understand the core concepts, and think in first principles, and then you understand this. When it is required, you can build the greater things, right? So as we have this chapter over here, so this is covered in this particular blog post or chapter. You can read it thoroughly. Then the way we do is by practicing, by doing with our hands. So for that I have chosen Jupyter notebooks in Kaggle environment, because you and I can try together. Kaggle is free. If you have an account, you can directly open this notebook and try things out with me. Okay, so in the description I'll provide the links for the Kaggle notebook, GitHub notebook, and the chapter, all the required details for you to learn the concept. Okay, so let's build things, right? So as I mentioned, classes are like blueprints, right? So that's why I found this image is very interesting. On the blue sheet there is some drawing. It's an architectural blueprint that you rely on to build the actual house out of it. So that's how the classes are defined. Okay, so let's define one class with the Python code. then we see how that works when we call it as an object. Okay, so this is a car class. So usually any car have what type it is, like make, model, and year. So these are the attributes for this. So these will be like, function inputs, assume in that way. Okay, so the new thing that you are seeing over here is the definition class and the name of the class. So we follow a naming convention over here. So first letter is capital, then all small. If you want to continue the naming convention, then instead of space, don't use space but use the capital letter. And init is a constructor. This is a special method within the class with which you actually define the attributes for your class. What are the inputs? Okay, so we see an example, then you understand it, but this is how you define it. So for each of your attribute, you create an self dot make the same name, and self dot model, self dot year, so that whenever you instantiate this, these attributes are available for that object. That's the idea. And you can also define methods, class methods, like this. So say you want to define start method. So self is the input, so that all these attributes are available over here. That's the idea. And then we are not using any of them, but we're just printing the car is starting. Simple as possible. Okay, just put to the ground level, learn it, and then build on top of it. So drive is another method, just to show you another variation. That's it. Self, the same approach. The car is driving, car is starting, car is driving. Very simple. So this is a kind of blueprint, just to represent visually. Then just for the reiteration, car is the class name. Init is a constructor. Okay, so it initializes specific attributes like make, model, year, as we have seen, and these two, start and drive, are the methods. Okay, that's it. Now let's create an object with that. So what we want to do is we want to create an object with input attributes as Toyota as a make, Corolla as model, 2023 as a year. So that is your object created out of your class car. Okay, so if you want to see the variables or attributes and their actual values, you can just print them. My car is your object. It has these three: make, model, year, right? So you can call them here, as well as it has methods start and drive, so you can call them over here like this. So if you run this, you will see the entered values are appearing over here. This is just print statements, those are coming from over here. So that's how you can create an object, and you can see the internals of it. Similarly, I'm creating another object, so the same class you can reuse again and again to create new variations out of it. Like your own house, you have one color for certain days and you want to change the color, you can change it, right? So something like that. So if I change this, I have to change all of this. So make sure you keep consistent with the naming convention. So what we are creating here is an object with BMW 3 Series 2024 model. So BMW 3 series, and the same methods: car start, car drive, like starting, driving. That's it. Okay. So that way you can create inputs and make use of them. I'll show you how to make use of them in the next example, and you can create methods and you can access them. Okay. So this example is, one model in this color, one model in this color, something like that. Okay. Now, for you to practice, you can create your own class. Okay, say that name of the class is person, and attributes are name, age, and occupation. And then add a method introduce, which has to print hello, my name is, the name is coming from here, and I'm a some profession or occupation coming from here. So those are the things, like, then that's your class, right? So you create an object using that class and then call the introduce method. So that's how you need to practice, and feel free to ping me in the comments if you wanna see the code for this as well. I'll make a simple video and share with you, or Jupyter notebook with you. And then, so another core concept that we want to cover is inheritance. Okay, so what is inheritance is, you have some base class from which you wanna inherit something and create another class. Okay, so let's see with one example over here. We already have car class, which consisting of make, model, and year. And then we are changing the era. We were using diesel cars, gas cars, right? Before. Now we are using hybrid cars, like, cars with electric cars with batteries. So we want to introduce that new class and make use of existing features of the old cars or parent cars. How can we do that? So that's one certain feature of the classes that helps you to, reuse of an existing class. Makes sure that, you don't write a repetitive code and your code looks very clean. Okay, so how you do that? Same class and class name. Here you're calling that particular parent class, so that's how you inherit. Then in the constructor of init, you call all the attributes from the parent, and whatever the new attribute that you want to add. Here we are adding battery capacity. Then how you call the parent class constructor? Instead of rewriting everything, what you do is you call the super method, that's the super, and you have already defined init, right? So call that and write the variables, attributes out of it. So there is a lot of variations happen. You don't need to write all of this, these days, but for clarity, I just put it down over here, so you can follow this approach. And then this is not available in the old parent class, right? So that's why you need to define it. Self.battery capacity is coming from here as a battery capacity. That's it. So that's your constructor. Then we are just creating two more methods. One is charge, because you want to charge electric cars, right? So the electric car is charging when we charge. That's one method. And another method here is a new concept that you're going to learn: how you make use of the attributes that defined in the constructor. Okay, as you see here, instead of we are just printing a static text, what we are making use of the attributes coming from here. So as you can see, the electric car, what's the car make and what's the model, are coming from here automatically, and then is driving. Make sure you use self because we are defining that way, right? So that's how you know a particular attribute is coming with respect to the data coming from the constructor. Okay, so that's the thing. Let's see some explanation around it. So as I mentioned, this is subclass of the car, and then super init calls the constructor of the super class, which is car, and we are just adding new attribute, and charge is a new method, right? Charge is a method, and drive is also a new method, and we are learning some new concepts over here to make sure of new attributes or old attributes automatically in the method. Okay, and so let's see. Electric car, maybe, you know, Tata, and whatever, XYZ, and 2025, and what's the battery capacity, some thousand, I don't know, AH maybe, right? Then this is your electric car. Okay, so that's the instantiation. So electric car has let's call this drive method over it. As you can see, the electric car self make is Tata XYZ, model is driving. So that way you can actually access it. And one other attribute, let's see that as well. Electric car dot battery capacity. Yeah, this is a value that we have assigned here, right? So that's how you can create inheritance or subclasses from the parent class, right? So with that, we jump into another core concept, which is polymorphism. Within the name itself tells you it's something that changing its behavior with the same face or something like that. Okay, so say these are all animals, right? So the same category, but the sound they make are very different. Dog sounds differently, cat sound differently, and cow sound differently. So that's polymorphism for the animals. Okay, I hope you understand the concept. So speaking where it varies, right? So let's define for our car class a new method. This is the function that we learned in the first fundamentals. So what we are doing is we are creating simple function name and input attribute, and what we are doing is we are assuming that this will be a class object. Okay, and this will have the methods in it. So here we are calling vehicle or drive method. Okay, so this is the class that you pass in will decide what drive it has to print or what class method it has to print. Okay, so let's say we are building this my car as well as my electric car. Electric car is a sub class, okay, for the superclass of car. Okay, and then this is one instantiation or object, and this is another object. And when I call the same function, okay, over these two different objects, let's see what the output is. Okay, so this is a base or parent class is just printing the static text the car is driving, and here this is electric car class, and under which the drive function is different, that's why it's printing this. So the same function is working differently based on the input class, which is known as polymorphism. So you learn, understand this idea and try to use it wherever it fits, right? Okay, so that's polymorphism. And for exercises that you want to try are create vehicle class with attributes as color, speed and a method drive, and create a car class that inherits from the vehicle. Okay, so this is now the subclass and this is the parent class, and adds an attributes make and a method honk. So add an attribute make, and honk is a method that you want to add to the car. Now bike is a class that also inherits from the vehicle. So this is the parent and this is a subclass, and you want to add attributes like motorbike or bicycle, type that might be motorbike or bicycle, that's what you want to add. And then create an object of car and bike. So we have created these blueprints and then make use of that. So that's what we are doing in the fourth point. Car and bike are the objects, and demonstrate polymorphism by calling the drive. Okay, so you try to do that, and if you struggle then feel free to make a comment in the discussion or comment in the YouTube. I'll try to pitch in and help you. And the final example, this is a fun example considered as a project, and this is something called animal shelter. Okay, so call it as an animal shelter application. So what you need to do is you define an animal class with attributes name, species, age and methods is make sound. So the same image that we have seen above, right? So that's what we are trying to build. Create subclass like dog, cat, maybe cow that inherits from the animal class, and override the make sound method, because they sound differently. Create a shelter class that can hold multiple animals with methods to add animals and display all animals, right? So this is a class shelter. You need to have two methods in it. One is add animals and other is display all animals, right? So here we make use of uh, list, okay, to add animals. So that's what we learned and we are trying to make use of it over here. And display, simply use print, right? So that's simple. And implement polymorphism by creating function to call make sound on any animal. So on any given animal, like dog, cat, which is subclass, to make sound definition or function, then it has to, show the sound it makes, makes sound. So make sure to do that by following this example. Maybe the code is available for you at the bottom, but don't try to see that first. Maybe you try for yourself, give it a try, then check your answer for yourself. Okay, that's it for the object oriented programming. I wanted to keep it as simple as possible and sticking to four simple fundamental core concepts. You master them and then you maybe use them later and improve upon them. So that's the idea. And then if you want to practice more, I put a link for this, W3 resources. It has some interesting uh, real life problems for you to practice. Take these examples and try to create your own classes, and you can share the Kaggle notebooks with me. I'll review it and give feedback. And then for you to show you, where actually we use classes, right? So as we all know, we extensively use Hugging Face Transformer these days. Call it for diffusers, call it for language models, text to text, text to image, whatever it is. All these Gen AI related tasks, we mostly rely on Hugging Face. Hugging Face is really great, whether it is data set or model, all you can find in one place, like our animal shelter, right? So let's see one example over here. So as you can see, this is a class. Okay, this is a class name. As I mentioned, if you wanna continue the name, don't use space but use a capital letter. So, and this is inheriting from the parent class pipeline. The pipeline is over here. This is coming from base.py, and you try to understand what it is doing by reading this. You don't need to worry right away, but this is just to show you as a demonstration how people write classes in real life. Okay, so this is a constructor. It has all these methods, and as you see, the super method is called to inherit constructor from the super class. Okay, and you remember error handling from the first class. This is how you error handle, and then you add new attributes. So this is fundamental, right? And then you have multiple different other methods in it: pre-process, forward, call, post-process. All these different methods are there, and that's how you can write a class in real life and make use of this. This is image segmentation pipeline, which actually take one input, like car image or some image, and then it actually segments out the foreground and background. That's how this works. Yeah, okay, that's all for today. I'll put the links in the description. Feel free to access them. Hope you like it. Keep practicing. Become a master of what you do. Thank you. See you again.